Hey, I'm Chris Zepp from Make Everything, and this might be the craziest thing that I've ever built. Check it out. All right, before we get started, a little bit of background. So a couple months ago, my friend Anthony Panza, who is a YouTuber and a professional BMX rider, hit me up that he had a crazy project that involved his Econoline E350 that he just picked up. He wanted to build a mobile box jump that would go over the van and be able to be self-contained on the roof so that him and his friends could take it out and use it in like a parking lot or on a road trip. I immediately took some measurements of the van and went onto the computer to do a drawing, and I started doing weight and load calculations for the type of steel and how we were going to build it. I spent probably 100 hours doing revisions of drawings, doing math on the steel and the different bends and everything we were going to need. We took a photograph of a lip of a box jump from a local skate park, and we extrapolated that to reach the 7'2" height of the deck of his van, and we did a ton of work to build this thing. Now, for those of you who don't know, I have a long-standing history in BMX. I rode BMX for many, many years, traveled all around the country and into Canada, riding bikes, filming for videos, and putting out DVDs with all my friends. So I love the idea of getting back into BMX and doing a project like this, especially for somebody like Anthony, who's got such great energy and really puts out awesome content. So without further ado, let's get into this. You can see some of the challenges we came across and how it turned out. Check it out. All right, so we started this out in the base of this Econoline E350 van. Now, this thing was stock when we got our hands on it, but it had definitely been well used. I think Anthony paid about $4,000 for it, and it has 100,000 miles on it. Now, from our original design, we figured that we were absolutely going to have to build some sort of a steel roll cage inside the van. Now, this is Matt. You've seen him in my other videos, and he's got a lot more experience working on vehicles than I do, so we went over to his shop to get this done. We're using 1.5" DOM pipe for this roll cage. And what we're going to do here is we're going to bend this tubing so that we can stretch it from the floor on one side of the vehicle to the floor on the other side and across the headliner. Matt's using an angle finder here to check the angle. And what we're going to do is lay it out on the floor with some chalk just to make sure that we get everything set up correctly. We don't have a big enough layout table at Matt's shop to do this on a table, so laying things out on the floor like this work out great. And since his floor is relatively flat, we can use this to make sure that everything's going to turn out correct. We're going to put 2 roll bars in this, and those are going to act as the foundation for the ramp build. We don't want to have the weight of the ramp rest directly on the roof rails of the van because they're really not made to hold that. We want to transfer the load down to the frame of the vehicle because the steel alone is going to weigh about 650 to 700 pounds, and that's without anyone actually like landing on it and banging on it. This is a 14-passenger Econoline van, and the weight rating of this vehicle is pretty high. So I'm not really worried about adding the weight to the vehicle itself, but I want to make sure that it can be properly supported and not cave in the roof. So we're doing our best to make these bars in one continuous bend. That's going to just make them that much stronger. So we bend one side, we reset this manual tubing bender, and then we bend the other side. The angle we sort of figured out and tuned as we went, and overall this process worked out really well. This type of ratcheting tubing bender is amazing what you can get done with it. You can really get a heavy wall tubing like this bent to a really precise and relatively tight angle with little deformation and without having to use anything really specialized or expensive. Once we got the first one fit in there and kind of figured out where it needed to go, we could make some marks on the headliner and drill up through the headliner, through the roof of the van to add some posts. We're going to be using the same 1.5" tubing to get up through the roof, so I drill a pilot hole from inside the van, and then I go up onto the roof with a hole saw, and I drill some holes through the sheet metal that we're going to be able to drop a tube through and then seal up later. I oversized these holes so that we would have a little bit of room to wiggle the tube around just in case we needed to kind of fit it and finesse it in the right way. Getting these bars in was tricky, and we had to take some panels off the inside of the van just to get them in and get them situated. We ground the paint off the floor of the van, and we added a 1/4" plate that we could weld right into the pinch welds on the actual chassis of the van. So underneath where this plate is the rail of the frame. So by welding through this sheet metal to the pinch welds, we were going to be definitely hitting a frame member versus just floating on the sheet metal of the, floor of the vehicle. Like I said, we want to transfer the weight directly down from the rail into the frame of the vehicle just so that nothing blows through the bottom of the van. When someone's going off the ramp and landing on the deck, maybe if they didn't clear the distance of the ramp all the way, they'd be putting a tremendous amount of force downward. And if we didn't put in these roll bars, you would essentially just go through the roof of the vehicle. Now, in order to stabilize these, we put a coped tube in between the roll bars on the left and the right side of the vehicle. And we made sure that we spaced these out and got them situated with a laser so they would be perfect. And we were done with the roll bar. Now, once all that work was complete, we started working back over at my shop. And the first thing I wanted to do was create some mounting plates for the actual deck of the ramp. This is a piece of 3/8 plate that I had left over from another job, and I'm using a steel cutting circular saw to cut it down into some little 6x6 inch plate sections. Now, if you follow along with me on Instagram, you know that I now have a CNC plasma table, which would have made this work way easier. But at the time that I did this project, I didn't have that yet, so I had to go a little more low tech and use the circular saw. This is still a really great method for cutting up plate if you ever have to do this type of work. And I recommend, getting a metal circular saw if you do any sort of steel work, especially if you have to do work, off-site in a more remote location. Now, for the actual tubing and the frame of the ramp and pretty much everything that we're going to do in steel on this project, I'm using 16 gauge, 2-inch by 2-inch square steel tube. And I've used this a lot for other applications. I've used it for a lot of furniture and other bracketry and stuff like that. What I really like about this tubing is that it's very light. It's under 2 pounds per foot, which when you are figuring out a project like this, figuring out the weight of the project is really, really important. And like I said in the beginning, I spent a really long time just figuring out how much tubing we were going to use, how much each panel was going to weigh, and how we were going to design and build this based on material. Now, using this thin gauge tubing, I wanted to make sure that I supported the pins that we were going to use to pivot the ramp around really well, because this thin gauge tubing would shear under a really heavy load. So what I'm using is a 1/2-inch ID, that's the inner diameter piece of tube, and I'm drilling out a hole in the end of the 16 gauge square tubing and welding in what's essentially a pin sleeve. And what you can see me doing here is I'm putting a brass tube in there, which is keeping the weld from sticking when I weld them into the tubes. Now, the actual frames on this are very simple. They're square or rectangular frames with a center member and some cross members just stabilizing and keeping everything together. It's not a very complicated welding job once you have all the pieces cut. But what was complicated was just making sure that everything was laid out correctly and everything stayed flat and square. You can see all my different members there with all the pin sleeves already tack welded in. Now, since obviously this is the first time I've ever built anything like this, I'm doing a lot of tack welding before I finish weld anything. Everything looked really good on the drawing, and in my head, everything should work out perfect, but not being 100% sure, I want to make sure that I don't do anything that's going to cause me to lose or waste material. So I tack weld everything into place, which will be strong enough for us to put this thing somewhat together before we, commit and use all this tubing. We used several hundred feet of tubing on this job, and it really adds up if you lose a 7-foot-long piece because you overwelded it and you can't salvage it. Now, while I was doing that, Matt was over on the ironworker punching some holes in the plates that are going to bolt the deck of the ramp to the roll cage that we built inside the van. Matt went ahead and used the TIG welder to weld in those pieces that we coped in over at his shop. And what we're going to have is we're going to have these little posts that come up through the roof, and there's going to be a 6x6-inch plate welded to those, and then the deck of the ramp is going to be bolted to that. Now, the idea here is that if Anthony wants to take the deck off the vehicle at any moment, he can. And since this truck's definitely has some miles on it and has some mechanical issues, we wanted to build this in a way where if he blew the motor on this van, he could buy a new van and we could, with little modification, put this ramp on a different vehicle. You can see the way it all sits on there, and we had to offset the rails a little bit so that they would work with where we put the mounting plates. Now, once we had that up there intact in place, we could hang the first section of the landing on the deck. Now, the original plan for this was to have the whole ramp fold up and over onto the roof, but you can see that it's just too big and there's just too much leverage to try to actually fold this thing up and get it up onto the roof of the vehicle. The ramp itself is 7'2" at the deck, and these sections leading down the landing are about 7 feet long. The entire thing is 7 feet wide. So once you add in all the rest of this steel, it's just too large to swing up onto the roof. So what we decided to do was we would be lifting the sections into place. Once we got the landing section set up and we knew kind of where it was going to lay out, we started to roll the tubing for what would be the lip. Now, this is a Harbor Freight tubing roller that I've modified with some of the Swag off-road upgrades, which helps me use a hydraulic jack and a pipe threader to power this thing and bend tubing like this. Now, like I said in the beginning, we used a photograph of another ramp at a skate park that, we all grew up riding our bikes at for the dimensions for this lip. Considering this is a box jump, not a quarter pipe or a half pipe, the geometry isn't the same. So what we did was we extrapolated that ramp and we stretched it from a 5-foot lip to a 7'2" lip. And you can see how crazy of a curve that was and how high the tube wound up bending. I'm bending full 24-foot sections here because I want to make sure that I have enough material to get a nice uniform curve. And I have to make this curve 3 times. If anything, we wanted this to be steep versus mellow because the jump isn't that long and we wanted to make sure you could go nice and high and then just kind of force yourself over it. Once we bent these curves, I laid them out with what was essentially a square using 2x4s, and I figured out where they needed to be cut with the bandsaw so that I would have the bottom where it would reach the ground and the top where it would reach the deck. Then I stacked all 3 pieces on top of each other and I was able to cut all of them the same. Getting these lips bent was really tricky, and normally when you roll tubing, you can expect a bit of a twist, but since this tubing is square and really need to be precise, the twist wound up being really difficult, and it made it very hard to lay this out properly and make it right. Now, the other thing I needed to do was I needed to split these sections so that they could break into 2. So what I did was I laid my tape along the back edge, stretched them, and then I was able to lay out that cut exactly where it needed to be. The other thing I needed to do was, using my bandsaw, was cut a sort of knife edge that would transition well with the ground so that when these things sat, they would be perfect. Just like I did with the landing section, I used a hole saw on the drill press and a vise, and I drilled holes for these pin sleeves that would eventually receive the 1/2-inch hardened pins that we're holding this whole ramp together with. I ordered several different types of pins from McMaster Carr, and those are what's essentially going to keep this thing together as hardware. Now, these guys are going to be traveling with this ramp, and they're going to be out on the road, and the last thing I want them to have to do is use wrenches to put this thing together and take it apart. So using pins was really important. Plus, a hardened pin is really difficult to shear, especially with these types of forces, so I know it's going to be really safe. That was another big issue with this build, was I wanted this thing to be super safe, and I never wanted to have these guys worry about it collapsing underneath them. I really wanted to overbuild it as opposed to underbuild it, even if that made it heavier, because I wanted to know that it was going to be able to take the abuse. Like I mentioned earlier, these sections got twisted when I was bending them. So what I'm doing right here is I'm running a long section of that pin sleeve material through all 3 pieces of the landing, and I'm doing that so that they'll all be forced to line up perfectly when I weld in the cross members. You can actually see a little bit of the warping on that front tube closest to the screen. So by having that pin sleeve material run through all pieces continuously, when I put in these cross members, I would be able to compensate for any of the gaps using my welder, but I knew that everything was going to be coplanar and line up right. This was really difficult to figure out, and it took a lot of tweaking and adjusting, grinding, cutting, all that stuff to get this to work out right. Now, the actual gaps between each section of the ramp are going to be taken up by 3/8 inch thick plates. It's 3/8 thick by 2 inch tall steel plates with holes drilled in them, or actually in this case we punched all the holes with the iron worker, and that's what these hardened pins are going to go through in order to allow these pieces to move. The original plan to have this thing fold relied on these pivoting brackets, but when we decided to have the whole thing be disassembled, we figured we would still leave these hinge plates in because it allowed the ramp to move a little bit and flex, which was really important. You can see the way I have to lay in that cross member and how I have to tack everything as I go just to kind of compensate for the twist and warp in this section. Now later on, you'll see that I have to go back and I have to compensate for some of this warp by cutting relief cuts, but for the most part, this piece came out really well. These curved sections were very, very tricky. Now the other thing I decided to do was weld some plates on the bottom here. That being said, this section in my mind was going to take a lot of load because this lip, your force going into it is going straight, and then that force needs to be converted and pushed upward. So there's a lot of force going straight at this lip. So having these joints be really, really strong was super important. Now, while I was working on that in the other room, my friend Steve was in the machine shop working on this wooden table that we set up just for this job and helping weld up all these sections. On this job, I absolutely had to bring in help. So Steve and Matt were a huge help on this whole project, getting everything put together. So Steve had welded up the top section of the deck. And what I did was I took the top section of the lip and I brought it into that shop and I lined the pieces up so that when I welded everything together, I knew that they would line up with the actual registrating pieces on the top. Now, hopefully that makes sense, but if you can imagine, I have 3 points on the deck that need to meet with 3 points on the lip. And if any one of those points is offset, my hinges just aren't going to work. Since I have that major twist in the bent pieces of steel for the lip, it was really important that I compensate for that and I properly align all my pieces of tubing so that this will all work together nicely. An easy way to do that was clamping them to the sides of the deck pieces, because as long as they work in that orientation, they'll work when I offset them back the 2 inches. Because of this, I wasn't able to use my drill press and fixture to drill the pin sleeves. I actually had to do this on site, kind of on hand, and what I did was I drilled a pilot hole and then I used a drill with a hole saw in it to get my holes through. And I walled them out a little bit so I'd have a little bit more room to play around and make sure that those pins were all square. Making sure that these pieces lined up was really tricky and very, very critical, because if these don't work, then the whole thing isn't going to go together. I put a level in place so that I could use a paint marker and make sure that everything was nice and flat across the top. Now, had I been building essentially a wedge-to-wedge pyramid, a lot of these issues wouldn't have existed. The fact that I had to roll this tubing and the fact that I rolled it and I had a significant twist and bend that I had to kind of fix made this really, really tricky. Now, I could have made these pieces have a wider tolerance, which would have involved using a longer pin. But my concern was if I allowed there to be too much movement between the lip and the deck, that as you rode up it, you would feel that flex and it would hurt the ability to kind of launch off that lip. If you've ever, tried to jump off of a piece of plywood on a cinder block, if that plywood is thin and loose, as you kind of get to the top of the cinder block with your little homemade ramp, you sort of lose the ability to jump. And I'm sure you've seen those fail videos on YouTube where someone on a mountain bike goes to do that and they wind up getting pitched forward and falling on their face. That's not what I want. Once we had those sections welded up, we could see how the lip actually looked. Now, this project involved a ton of just hand labor of moving stuff around. So what we did here was we pulled the deck outside, put it on the roof of the van, and then we used those pin hinges to clip the first section of the lip to the top and hang it off there. One of the other considerations on this build was that I needed to make sure that we didn't actually damage his van and didn't give an opportunity for the ramp to swing down and break a window or damage a door panel. So as we're outside looking at this, kind of figuring it out as we go, I'm thinking about ways to transfer load and make this thing safe, make sure that it doesn't hit their vehicle. Right now, all these ramp sections are as light as they're ever going to be. They have very little support structure welded in them, and they don't have any wood on them. The wood is going to add a tremendous amount of weight on its own. So here you can kind of get an idea of where we're headed with this lip section. So we use some pin hinges to put the two sections together, and we sort of stretch it out to get an idea of what that curve is going to look like. And then I use a cutoff from the bent piece of steel as a guide, and I clamp it in there so I know exactly where the lip is supposed to be. This is the first opportunity we got to see the lip with any piece of material stretched across it. And when we saw this, everyone got super excited because we knew this thing was going to work out. What I realized quickly was that I was going to need some sort of a kicker for the lip to rest against so that it would have extra support and not wobble so much when it hit the deck. So you can see I'm welding on these little tabs that are going to hang down, and the top section of the lip is going to rest against those. These wind up being really important. The other thing we decided to do while we were out here was we decided to put the pin hinges around this bridge section between the two sections of the lip and weld a piece of plate to the bottom of that. Now what this is going to do is it's going to keep that joint, that open floating joint, from flexing or stressing, and it's going to give us a much better purchase for the leg to support the actual lip in that center section. Like I said earlier, if you can imagine, as you approach this and the mass of you on your bike, you're pushing a lot of force straight into the van, a horizontal force, and that force needs to be converted into a vertical lift force. Now, if we don't properly support this, the lip is just going to buckle right there in the center. You can already see the way it's supporting the weight as I'm pressing down on it, and you can see the way that some of those pins go through the holes and how this is sort of going to work. Now, doing this work outside with it set up was really important. You know, there's only so much that you can mock up and figure out in the shop, and it's really important to get outside and work sort of directly on a project like this to solve problems. Now, you can see kind of the way that this thing comes apart and goes together. You pull the pins on the section in between the two sections of the lip, you pull the pins on the section that attaches to the deck, and then you're able to move the sections around independently. Like I said, they were super light in this orientation, so they were easy to move around. Now what I needed to do was fully weld those bridge sections that I made between the sections of the lip. It was really important that these didn't warp because I made them exact out in the field, so I wedged a bunch of material in between them so that if they did warp, it would be outward, not inward, and that clamp would compensate. The other thing that I did here was I welded some more of that 2x2 tubing to make a leg. What we wound up deciding later was that all the legs on this were going to need to be adjustable. So I later go ahead and I get some leveling feet that you would use for pipe scaffolding, and I modify it to work inside all 6 of the legs on this, which really helped and made this thing work on any terrain. With the lip section complete, we went back to the landing so that we could work on that and fine tune it. You can see how each tail coming off of the deck has 2 pin hinges, and each one of those pin hinges goes on the side of the material, and then a pin goes straight through everything. This is a really, really strong connection. You've got 6 pieces of 3/8 inch plate, and you've got 6 1/2 inch hardened pins holding everything together. You can see a problem arose right there, though. The way that the landing orients itself against the deck, there's really no way to make sure that you wind up on top of the deck, and it kind of created this little wall. As we laid out the landing with strips of material to straighten it out, we could find a couple of the problems that we were going to need to resolve. One of which was that we were going to need more kickers, just like we used on the lip section, in order to stabilize the landing. What I did just there was I traced out a section in between the kicker and the deck with some cardboard, and then I brought that piece of cardboard inside and I traced it onto this different section of material. This is 2-inch by 3-inch tubing, and I'm going to cut this into a custom sort of triangular piece, and that's going to act as a gusset between the 2-inch material on the flat and the 2-inch material that's acting as that kicker and stabilizer, which is going to help support the load of the lip and the landing. These pieces wound up being really important, and I'm really glad that we took the time to make them because it just added that extra safety and security to this whole build. I will say they were a little bit difficult to cut though. Cutting anything at this sort of height and trying to get it precise was not that easy, and we wound up having to do a ton of regrinding. Here you can see Steve welding in the gussets on the landing side, and you can see the gussets on the lip side are sitting in place waiting to be welded. Obviously, this added weight to the entire thing, but in the end, it made it way, way safer, and I never had to worry about the lip or the landing shearing off under extreme load. Getting this deck worked out was super important, and I'm really happy with the way that it looks. All right, so we're back at the shop. There was a crest in this. The ramp was up in the center, so what I did was I cut some relief cuts in the bottom of this tube in the center and the top of this tube on the sides. And then using a clamp, a board, and a wedge, I'm able to actually press this whole thing down, spread those relief cuts, and then I'll go back and re-weld all these, and it'll make everything nice and flat. So this is a really useful trick if you're ever dealing with tubing that's warped. Obviously, you are taking some of the strength out of the tubing because it's no longer a continuous piece of metal, but if you properly weld those seams back together and you add some gussets, you can really correct a lot of errors like this. So like I said, I used the bandsaw to cut some reliefs, I used a piece of 2x4 to stabilize the whole thing, and then I re-welded all those sections, and it really helped get the bend out of this section of the lip. This was super important because when we laid the plywood on this, you could see it right in the middle, and I didn't want to have anything that would affect the performance of the lip. I really wanted to make sure that when someone rode up this, it didn't feel like it had a lump or a belly in the middle. Now, while we were working on this, we were leaving some sections of the ramp outside. We spent weeks on this project. So once we were done welding everything, we had to go back and wire wheel all the parts to make sure that it would receive paint well. So Steve's wire wheeling one of the sections of the lip, and I'm finishing up welding some of the other sections in the background. The other thing we noticed was we let Anthony drive around with the deck for a while, and he could hear the roll cage kind of rocking back and forth. So in between sections of this, I decided to take some 1x1 tubing and cope it in to make some angled brackets that would reduce or essentially eliminate any rocking back and forth of the cage. We wanted to make sure that this thing wasn't going to shake back and forth while he drove, because once you added the weight to the top, it really wanted to move around. Building this cage and building these support bars inside the van was really critical to the whole success of this project, and I'm so glad we did it. And you can see here I had to make this one a little bit different. Behind that column on the left is the air conditioning condenser and piping, so I needed to make sure that someone would be able to get to it if they ever needed to service it. I was also doing my best not to put too much weld spatter on the interior windows of this car, but this thing was in pretty rough shape, so it was all fine. All right, so it's been a couple of days, and I took all the steel and all the wood, we painted everything. I used the Rust-Oleum heavy metal primer on the raw steel, and then I used the Rust-Oleum flat black paint on top of that, just because this stuff's going to live outside all the time. Now today, the shop doesn't have any power, so there's not much more we can do except maybe run the welder off a generator. We're going to get this whole thing assembled, get all the wood on in the right spot, and we're going to try to top coat it. So it's been a long road to get here, but we're close. We're in the finish line. So getting everything painted was a huge accomplishment, and we didn't have power at the shop for about a week during this build. It actually was good though, because it gave me some time to kind of take a step back, clean up the metal, make sure that everything got painted, because it's always going to live outside. So it was really important it got a good coat, and then we could start installing. So to cap these, just to make them a little safe, in case you hit your head on them or anything, we got these plastic caps from McMaster. These press right in, and I can drill a little weep hole in there if I have to, and they're just plastic. They're easily replaceable. We'll do those up top too. Now once we got everything installed on the van, we're going to install 3/4 inch decking on everything. So the top deck gets 3/4 inch material, the landing gets 3/4 inch material, and then the lip gets 2 pieces of 3/8 inch material in order to create that curve. The way that we're going to attach the material to the tubing is with 1.5" stainless steel self-tapping screws that I got from McMaster-Carr. These are meant to drill through metal with a self-tapping tip, but because we were going through such thick material, we wound up having to drill a pilot hole. I did a lot of research on these before I decided to use them, and I did many test pieces with different screws to make sure that these would be strong enough and not brittle or break. I really want to make sure that this deck stays in place, and part of the stability of this whole project is built into these screws. Screwing this 3/4 inch plywood to this steel is going to help stiffen everything up and make it nice and rigid, and the fact that the screws are stainless, I never have to worry about them rusting out. So now we've got our first opportunity to sort of see the landing as it interferes with the deck. And you can see that there's a little bit of a gap right there that we're going to need to compensate for and cut the deck down so that it won't create some sort of a bump that you'd have to hit into. I grab my track saw and I run the track saw against the top, and that just helps soften that angle and makes it a little bit easier to get from the landing up to the deck. You can also see those leveling feet that I mentioned earlier. Again, those are for pipe scaffolding, and they interfere with the bottom of those tubes, and they allow us to really fine-tune the landing so that everything can snap together properly. Anthony went with this really crazy sort of teal color for everything on this, but before we did that, we used a stain-blocking oil-based primer to prime all the plywood on all sides. So the front, the back, and all the sides got hit with an oil-based primer. All right, so when we tested it out, we noticed that these legs needed to be able to be adjusted. So just like on the landing side, we got these jack levelers for pipe scaffolding, and these, stock are too long. So what we're gonna do, we're gonna cut maybe 5 inches off of these, and I'm gonna cut these down so that they fit inside there, and we get a little bit of adjustment. These scaffold legs wound up being the perfect solution for leveling and tuning the performance of the ramp. Now, the way these things come, the leg has sort of a notch in it that was binding up on the tubing. So by cutting them down, I was able to unscrew that sort of wing nut and then screw it back on, and these things worked out perfect. You can see now we're hanging the top section of the lip, and we're going to be installing the legs again and leveling them out. And this will be so that I can stretch that thinner 2 layers of plywood across it and start getting that decked up. There's a lot of things going on at once during this project. No one was ever really standing around and kind of waiting for the next thing. If someone was painting, then another person was welding, or if someone else was kind of fitting parts, someone else was cleaning up parts or repairing a section that needed to be re-welded or maybe finish welded. With the sort of sequence of events being, a lot of tack welding and then finish welding, you always have to kind of be ready and make sure that you don't forget to finish weld and really tidy something up and make it strong. One of the things that we noticed during the test fit was that the brackets I made, being square, needed to be ground to accept that contour. Otherwise, there was pressure from the plywood to the bracket, making it so you couldn't get it off. Now again, we're going to be using a 3/8 inch plywood, but 2 layers on the lip side, and this is going to help you actually get around that curve. Initially, I had designed this to run the plywood the long way, but after thinking about it and thinking about what would be stronger and hold up longer, running it horizontal made more sense. The curve is generally very gentle, and by transitioning it over 2 pieces, it actually works out really well. If you've ever seen someone build, a half pipe or a quarter pipe, skateboard or BMX ramp, you know that it's always beneficial to layer multiple pieces of plywood, and it's going to get you better transition and a better curve long term. This is where those screws were really important, because they have to be strong enough and grab the steel well enough to pull this wood in to compensate for that curve. And I need to make sure that that center transition piece is nice and you don't feel that bump as you ride from the bottom section of the lip to the top section of the lip. And here's a little trick if you ever have to do something like this, screwing off into a ramp. You can clamp a piece of 2x4 across it and use it as a little step, and so you can work further up without sliding down the ramp. Now at this point, we'd been working on this project for weeks and we were fighting daylight all the time, so we wound up painting and finishing that in the dark. The other really important thing for this ramp for Anthony was to put his logo on it. So I used a Silhouette Cameo, which is a little die cutter, and some Aura Mask to make some stencils that we would be able to spray paint onto the ramp. Now I will say the Aura Mask is something you see guys in sign making use a lot. It did not stick well to this painted surface. I'm not sure why, but this wound up actually being really tricky. In the end though, I am happy with the way the stencils came out. And yes, it was Anthony's idea to put my logo on there, and I am very thankful to him for that. It was really awesome for him to include me in this project and really make it something that we did together versus something that I built, for him to utilize. So I was really happy to see my logo nice, big, and proud on this lip section of the ramp. So with all these pieces done, we could load everything up onto the roof. Now I designed this in a way that the pieces are light enough that really 2 people can put this thing on the roof of the van. Me and Matt did it a few times, just the 2 of us. Obviously the more people the better, because the sections are pretty heavy. And what we found was if you had a 3rd person up on the roof and 2 people on the ground, it was really not that bad to get everything up there. The total weight on this thing was about 650 to 700 pounds with all the sections. So we used some nice big straps to strap everything down to that roof deck, and knowing that everything was secured and welded back down to the frame of the van really made me feel comfortable about them driving around with this up there. And now you can see the setup. So you take down the 2 sections of the lip and you can set them off to the side. And then you take down the 2 sections of the landing and set them off to the side as well. We like to set up the landing section first because it's a little bit easier. And essentially it gets held up and the pins just pop right into place. We made sure that the holes were big enough that it would be easy to get those pins in without having to really use any hammers or any special leverage. Then you can add the legs and you can level them out as you go to get the 2nd section of the landing installed. Having the leveling legs on there made a huge difference. It made it so that you could very easily make sure everything lined up properly, because if anything's out of square, the pins just don't want to go through it. Now the lip goes on the same way. You hang it off the side, add the pins, you can add the leveling feet, and just make sure the transition looks correct, and you can add on the bottom section. Again, being able to level it made all the difference. This thing looks awesome when it's all set up, and the leveling feet make it perform really, really well. And that's it. You can see the way the ramp performs. Anthony rode it for a couple days. We had a bunch of other guys come out and ride it. Yes, the van moves a little bit, but overall it handles the impact and the force really, really well and stabilized amazing. I'm so happy with how it came out. And now you can see how we disassemble it. So you take off the bottom section of the landing and slide it up to the roof. Take off the top section of the landing and slide that up to the roof as well. And because everything is plywooded and steel, everything slides relatively easy. Now you can go over to the lip, take off the bottom section of the lip and kind of set it aside. You take off the legs that are leveling the lip and take off the top section of the lip as well. And that gets flipped over and put on the roof to kind of, contour that angle and give you almost a roof on top of all these sections. And you can see how important it is to paint the bottom of the wood, because that's actually going to protect everything and be exposed to the elements. And then that last section of the lip goes up top. This thing came out incredible. It rides amazing. I got to spend a little bit of time riding it. It looks so cool, and I'm just so happy with the way this project came out. All right, that about does it for this video. Thank you so much for watching. This was an amazing project. Thank you to Anthony, Austin, Matt, Steve, everybody that was involved and helped along with this. Thank you to Lincoln Electric for providing me with the amazing equipment, the welders, and all the stuff that we used to build this thing. If you have questions, leave them down in the comments below. Don't forget to follow my Instagram right here, @MakeEverythingShop. Follow Anthony Panza on Instagram. Go to anthonypanza.com to get smash the like button, get some of his stuff. Thank you for watching. This was great. This is why I started my shop, to do fun projects like this. Like this video, comment with questions, subscribe to my channel, and I will see you on the next one.